Welcome to the session on estimation of steel quantities. Here in this figure you can find a bunch of steel laid down of various diameters. Now let us calculate the weight per meter run of each of the steel materials of different diameters and estimate the quantities of this when it is laid down on the roof or beam structure. Now the weight per meter run of the steel is calculated by using the formula volume into density. The volume of the steel material is calculated by using the formula area of the diameter of the steel and length, and always we are going to calculate this for per meter length. The density of the steel material is approximately taken equal to 7850 kg per meter cube, that is 7850 kgs per meter cube. Now let us estimate this with respect to the diameter of the bar, where the diameter will be substituted in terms of mm. So area is calculated by using the formula pi d square by 4 into 1 meter is 1000. The density of the material, which is kg per meter cube, has been converted into kg per meter cube, and we obtain the final fraction as 0.006165 d square, where this is the weight per meter length. 1 meter length of the steel will be equal to 0.006165 d square, and the weight finally it is measured in terms of kgs. These are the reinforcement that is being provided on the roof slab. You can find it, the main bars and the distributions, the column reinforcement, the longitudinal reinforcement of the column with the core blocks. Just have a look on all these things. We are going to estimate one by one what is the total length required for this entire roof, or for the column sections or the beam sections. Here also you can find that the bars are being overlapped. So let us also take into consideration this quantities also in our calculation. So first let us calculate the weight per meter run of various diameters. Like 5 mm diameter bar, it weighs 15.15 kg per meter, that is 150 grams per meter length, and this is obtained by substituting 5 mm diameter in this formula, that is 0.00616 or 7 d square. We substitute in this formula, I can make it as 0.00616 into d square. D is substituted in terms of mm. We are going to get the weight in terms of kg per meter. Now similarly you can substitute 6 mm diameter bar and get the weight per meter run as 220 grams per meter length. Now I can see the different weights per meter length of various diameters. All these are in terms of kg per meter cube. Sorry, measure in terms of kgs per meter length. Now let us take an example of a singly reinforced beam and try to estimate the quantities of the steel that has to be used for this beam sections. Now this is a typical isometric view of a beam. We know already the span between the two walls is called as a clear span. The center to center length is called as an effective span. This is the bearing, the thickness of the wall. All these things will be taken into considerations for the calculation. This is the breadth of the beam, the depth of the beam. Now I am going to show you now the 3D view of the reinforcement. These are the reinforcement that are provided for the bending moment. We call it as flexural reinforcement. 2 bars have been provided straight, keeping in view that as per the code specification, minimum 50% to be taken to the support. And 2 bars have been cranked and taken up to the top, where the angle of inclination is taken as 45 degree. Here. Now you can see the top bars, which are provided nominally, called as anchor bars or holding or anchor bars or whatever you call, which are used to keep the reinforcement in positions, the stirrups in positions. We are going to have these top bars. Now you can find the stirrups placed at a regular interval. Now our duty is to find out the total quantity of this main reinforcement, that is 2 straight bars, 2 bent up bars, 2 straight bars provided at the top called as anchor bars, the stirrups, the quantity of stirrups along with this bends, hook. All these things we have to find out. Now this is the typical longitudinal section of a beam having a clear span of 5 meters with a bearing of 300 mm at the ends. The depth of the beam is 500 mm. For the calculation purpose, we have shown the hooks here at the ends, means to say this is a mild steel bar. In the next example, we'll show you about HYSD bars or taut steel. Only for the purpose of calculation, I made use of this hooks at the ends. Now here you find a gap here between the end of the beam and this reinforcement. We call it as side cover or end cover, sorry, we call it as end cover. In the cross section here, this is a cross section which has been taken at the center of the beam, that is this one. We are taking the cross section. You can find here 4 bars of 20 mm dia, which is the main steel provided at the bottom. So all these 4 bars you can see it here. And these are the 2 holding bars provided at the top. And these are the stirrups provided all along the length of the member. This is the stirrup, spaced at 250 mm center to center. Now here you can see the cross section of the beam support, cross section of the beam at the support. This is a knee very close to the support we have taken, where after the bars have been bent up. So this 4 bars which were there earlier at the bottom is cranked here at an angle of 45 degree. I'll show you that in the other figure. So this goes to the top. These 2 bars which goes here will be shown here at the top. Okay, just have a look on all this drawing. Making use of this drawing, we are going to estimate the quantity of the steel. If I say length of 1 straight bar, it has to be taken from here all along the length of the hook to the end of the hook. This is 1 straight bar. If I say 1 hook, 1 crank bar or bent up bar, will take like this, come down like this. This is how you measure the bent up bar length. So all this will show it in a calculation. We have reproduced this figure once again. Now let us start estimating the quantities. So length of 1 straight bar, as I explained earlier, is to be measured here. It is the clear span from here to here of length equal to 5 meters plus 2 times bearings. There is 1 bearing here, there is another bearing here, 2 bearings minus 2 end covers. You can find this is the end cover. of 25 mm. You can see it at both ends, minus 2 end covers plus 2 hook length. We have to take the length of this hook. So this will be taken equal to, the length of one hook will be taken equal to 9 times the diameter of the bar. One hook length will be taken equal to 9 times the diameter of this bar, whichever the bar we consider, whether it is main reinforcement at the bottom or the nominally provided top reinforcement, which are called as anchor bars. So this is the formula we are going to remember as per the code specification. Now, the length of one straight bar from this end to this end will be equal to 5000. We are putting in terms of mm. This 5 meter is being converted into 5000 plus 2 times the end bearings minus 2 end covers, which are shown here at the top, plus 2 times hooks, one hook here, the other one is here. So 2 times 9 times of the diameter of the bar we have used. It's 20 mm, so 2 into 9 into 20. Totally the length of it works out to be 5910 mm, which is equal to 5.91 meters. Similarly, we'll calculate the length of one bent up bar. So bar will come like this. So I have to take this additional crank length. So that is equal to n. N indicates whether the cranking is done on one side or two sides. Now in this figure you find that cranking has been done on two sides, therefore n value will be taken equal to 2, and this extra length will be taken equal to 0.45 times of h. H is measured from the center of the top reinforcement to the center of the bottom reinforcement. This is the h value. We measure it from top to the bottom, or center of the bottom reinforcement. That is nothing but h is equal to this 500 minus the top cover minus half of the top reinforcement minus the bottom clear cover minus half of the bottom reinforced. That is the h value. You can find it here. So now here the number of hooks at the end bars will be 2. The bends that we are going to make. H is equal to, as I said earlier, it is 500 minus 2 times the top and bottom cover. There also it is being taken 25 here, top cover, the bottom clear cover is 25. 2 times the center of this one to the center of this one we have taken, that is half of 20 mm. So totally the h distance works out to be 440 mm. Actually it is not hooks, it's a number of bends. We'll make the correction in the other diagram. It is not number of hooks, it is number of bend here. This is one bend, this is another bend. Now the length of one straight bar we are going to calculate because it is of 20 mm diameter. So here it is the number of bars into length of one straight bar plus number of bent up bars into length of one bent up bar. Totally we had 4 numbers in the center. As you go towards the support, 2 bars have been extended to the support and 2 bars have been taken to the support. In the earlier slide we have calculated the length of the straight and the bent up bars, and their lengths are 5.91 meter is the length of straight bar. Length of bent up bar is 6.31. Totally we get 24.44 meters. Quantity of steel, we'll just make a correction here itself. That was a mistake we had done. I'll just show you. And one more correction was, it was not length of the hook, number of hooks, it was number of bends at the end of the bar or at the bends near supports. We can call it as near supports. I'll come back to this one once again. So it is 24.44 meters. The quantity of steel is estimated by using the formula total length into weight per meter length. When you calculate the total length here, this is the total length of the bar. Sometimes you have to take into consideration the overlap length, as I showed you earlier, or the wastage that has to be considered. Sometimes length of 1 meter, half a meter of steel bar, when it is cut from the bunch, will become waste. Therefore, we are going to take those things into consideration. For that, we are going to approximately take 10% of the total quantity. So now the formula can be rewritten as 1.1 times the total length of the bar into weight per meter run. So 10% extra is nothing but 0.1. 1.1 into 24.44 is the total length of the bar. Yes, into weight of this 20 mm, as you observed that in the very first beginning class. For 20 mm, it is 2.46 kgs. So total quantity of 20 mm bar required is approximately around 66.13 kgs. So this steel, what we have to provide for the main reinforcement is equal to a quantity of 66.13 kg. Now let us try to find out the quantity of the top rod required, which is of 10 mm diameter. We have got only 2 bars, the number of bars is 2, the diameter of the bar is 10 mm. So 10 mm diameter will have a different weight per meter run. It will be around 0.62 kg per meter, that is 620 grams per meter length. Now let us estimate the length of one straight bar in the same manner as it was estimated for the bottom reinforcement. It is equal to clear span plus same bearing minus 2 end covers plus 2 hooks. So it is 5000 plus 2 times of this bearings minus 2 end covers plus 2 into 9 times the diameter of the bar. Now the diameter of the bar is 10 mm. So the length of this works out to be 5730 mm, it is 5.373 meters. The total length of this, we have got 2 number of bars, 2 into this length of 1 bar is 11.46 meters. Now the total quantity of 10 mm bars diameter steel is 1.1 times the total length of the bar into weight per meter run. It works out to be 7.81 kgs. So 10 mm we have to purchase of 7.81 kgs. And this icon next will be on stirrups, which is of 8 mm diameter at 2 leg stirrups spaced at 250 mm center to center. We'll have the cross sectional view of this one. There is a cross sectional view. We have provided the bottom cover as 25 mm and top cover as 25. The side covers as 25 mm. This length is taken equal to 6 times the diameter of the bar. So 2 extra length has to be taken. Now the size of the beam was 350 mm by 500 mm. This is the size of the beam. Now you have to estimate the length of one stirrup. Now the length of one stirrup will start from here. We go like this, calculate like this, come down, take this bottom width, take this vertical height, then take the additional hook length. So this is the length of one stirrup. This is one leg, this is another leg, two leg. The diameter of that is 8 mm, which is longitudinally spaced at 250 mm center to center. Now let's just estimate the breadth of the stirrup. It is equal to 350 mm minus these two side covers. So it becomes 300 mm here. Similarly, calculate the depth of this stirrup, which will be equal to 500 minus top cover minus bottom cover, we'll get 450 mm. This is plus 2 times the 6 times the diameter of the bar. Now we can get it here. This is 450 plus 300 plus 450 plus 300 plus 2 times 2 into 6 times the diameter of the bar. The diameter of the bar was taken 8 mm. Totally length of one stirrup is equal to 1.6 meter. This is the one stirrup. Now we have to calculate the number of stirrups. Number of stirrups is equal to clear space span divided by spacing plus 1 meter. What is this clear span? If I just go back to the previous slide here, it is taken from here to here. We are placing this between this, all these stirrups. Therefore, clear span is 5000 mm. This is what we have taken here, 5000 divided by the spacing 250 mm. One additional bar will be provided at the end. So totally 21 numbers of stirrups has to be provided. So what is the total quantity length of the stirrups? Total length of the stirrups will be equal to number of stirrups into length of one stirrup. It's 21 into 1.6. We're going to get 128.1 meter. And the quantity of steel is estimated with the usual formula, 1.1 times the total length into weight per meter run. For 8 mm diameter, it is equal to 390 grams, that is 0.39 kg per meter. So get this quantity of, we get the quantity of 54.95